Hey Trig, this is the second half of section 3.5 notes. We just have this backside left to go, example 4, 5, 6, and 7. But before we do that, I'm going to talk a little bit more about domain because I think there's still a little bit of confusion about that. So when we talk about the domain of x, really the two things that we have to look at is the two domain errors that could possibly occur, okay? One of them is easier to solve for than the other one. So the first one is we want to make sure that we're never dividing by 0, and then the other one we want to make sure that we never have a square root of a negative, okay? The first one, this division by 0, is a little bit easier to solve for than the other one, but we're going to do an example of each, okay? So this guy here, we're trying to figure out what x cannot be equal to, and the thing that I know is that I don't want 4x minus 3 to be 0. Whatever I plug in for x, I don't want that to come out to be 0 because then I would end up dividing by 0. So this one's a little bit harder to do in your head, and I did that on purpose because I want you to get used to writing out the work. I know that 4x minus 3, I do not want that to be equal to 0. Okay, that's just putting that in symbol form. Then what I can do is I can just solve from there. So add 3, 4x can't be 3. And then if I divide by 4 and divide by 4, I know that x cannot be 3/4, okay? So that would be finding the domain for this function. X can't be 3/4 because if I were to plug in 3/4 in for x here, I would end up with 1 over 0. And that's bad, and I don't want that to happen. Okay, so just simply take the bottom that you have, set it not equal to 0, and then just solve it, and that will tell you what your domain is. Okay, so that's addressing that first domain error. The second domain error, we don't want to divide by 0, so that's, I gave you this example, and again, we're still using 4x minus 3, but now it's underneath of a square root. So what I don't want 4x minus 3 to be is a negative number. A negative number would be bad. So what I'm going to do to start with is I'm going to take 4x minus 3 and I'm going to set him equal to 0, kind of like we set him not equal to 0 over here. And if I do that, we end up with 3/4, just like we did over here. But after I get that as my answer, I'm going to put that onto a number line. And what happens here is I'm going to test numbers that are over here, and I'm going to say, okay, does numbers that are larger than 3/4 work? Can I plug them into this equation and them give me a nice number? Or do I have to pick numbers that are less than 3/4? Do those numbers work? Okay, and so what I do is I pick a test point. Like, what's a really, really nice number on the right side of 3/4 that I can plug in? Well, I can plug in the number 1. Right? What's a really, really nice number on the left side of 3/4 that I can plug in? Well, I can plug in the number 0. Okay, so we're going to practice plugging those numbers in and seeing if it gives me something really nice. Okay, so I'm going to start by plugging 0 in, and I do the square root of 4 times 0 minus 3. Well, 4 times 0 is going to go away, so this gives me the square root of negative 3. Can I take the square root of negative 3? No, that does not work. So numbers that are less than 3/4 are numbers that are not going to work. Now, if I plug 1 in, the square root of 4 times 1 minus 3, that would just be the square root of 1. And I can do that. I can take the square root of 1. So numbers that are larger than 3/4 work. Okay, those are good. So in this case, the domain would be x's have to be greater than 3/4. Okay, the last thing that I'm going to look at is, can it be 3/4 exactly? Does this need to be equal to? Okay, we're going to find that out here in a second. So if I plug 3/4 in there exactly, 4 times 3/4 minus 3, that's just going to give me 0. Okay, and really it's the square root of 0. Can you take the square root of 0? Yes, you can. So I want to have that to be equal to, and so that's kind of how he works out. Okay, so the first domain error where we're just setting him not equal to 0 is a lot easier than actually having to do the number line part, but that just kind of breaks down how you would address both of those domain errors. Okay, they're going to have us do this in example 4. Okay, so let me erase some of this stuff. All right, they give us f of x as a square root, and g of x is x squared minus 5. That's a quadratic function. They want us to find g composed of f and f composed of g, okay? So g composed of f, I'm going to write that over here, g composed of f of x, and I like to always write it with a parenthesis instead of like the fog and the goth, okay? And then I'm going to do f composed of g of x, okay? And what I like to do, so this means that f of x is getting plugged into the g of x, okay? So I'm going to start with the outside function, g of x, which is x squared minus 5, okay? I'm rewriting what g of x is, except instead of putting the x in the spot, I put parentheses in that spot, okay? X squared minus 5 is my outside function, and then f of x is going into that. So where the x was, and the parentheses are now, I'm putting my f of x function, okay? So x squared minus 5 is what I started with. I'm replacing that x with the f of x function, okay? And then I just simplify. What is the square root of x squared? The square root and the x, or the square root and the square root is going to cancel each other out, so this is x minus 5. Okay, that's what g composed of f of x is. Okay, now they're going to have us do f composed of g, so that means g goes inside of the f function. The f function was the square root of x. Okay, and now instead of that x, I'm going to put the g function, I'm going to plop that in there. So x squared minus 5 goes in there. Now, a lot of people think that I can take the square root of that x squared, and this would just be x and then the square root of negative 5, but that does not work. You cannot do that because the x squared minus 5 is trapped together. So really, that's all that I can do. I can maybe drop my parentheses if I wanted to. X squared minus 5, that's all that I can do. Okay, so we have g composed of f and we have f composed of g. Now, they want us to go back through and they want us to find the domain of each. So, things that I can and cannot plug into that function, all right? So, what am I allowed to plug in for x and what am I not allowed to plug in for x? Well, the two things that I have to look for is dividing by 0 and a negative inside of a square root, okay? Well, x minus 5 doesn't have a fraction, so I'm not worried about dividing by 0, and it doesn't have a square root, so I'm not worried about that either. So, the domain for this guy is all reals. I can put in anything I want to in for that, and it will work. Okay, now this one, I have to worry about that square root thing. So what I'm going to do is, just like we did up here for this domain error, we're going to set the inside equal to 0. So x squared minus 5, we set that equal to 0. I'm going to add the 5 over. So x squared equals 5. And then I take the square root. Okay, and when we put the square root in there, it's plus and minus the square root of 5. Okay, plus and minus the square root of 5 is like 2 point something. I don't know, maybe like 2.2 or something like that. I don't know. It doesn't really matter. Now I'm going to put it on a number line, and I have two numbers to put on a number line. I've got the negative square root of 5, which is 2 point something, and I have a positive square root of 5, which is positive 2 point something. Okay, and now I need to choose out of these three intervals here, which ones work and which ones don't work. Okay, so let's pick a test point. If this negative square root of 5 is negative 2 point something, let's do negative 3. Between negative 5 and negative square root of 5 and positive square root of 5, 0 works really nice. And let's do positive 3, and let's plug those guys in. Okay, so I'm going to start by doing negative 3. If I do negative 3 and I square that, that becomes positive 9, and I have 9 minus 5. That's 4. The square root of 4 works out nicely, so this will work. Okay, now if I plug 0 in, 0 squared is 0, minus 5, that's going to be a negative 5, and I cannot take the square root of a negative 5, so that's bad. And then if I plug a positive 3 in, positive 3 in here, 3 squared is 9 again, minus 5 is 4, so that will work. Okay, so for the domain of this function, I would say that x has to either be less than or equal to negative square root of 5, negative square root of 5, or x has to be greater than or equal to positive square root of 5. Okay, that's what these two little bubbles are saying here. X is less than negative square root of 5, or x is greater than positive square root of 5. Okay, so that's the domain of that one. All right. Okay, example 5, 6, and 7 go by a little bit faster. Write a function as a composite function. So they say h of x is this function here, and they want us to write it as two functions combined into one. So I'm going to name those two functions f of x, and I'm going to name the other one g of x. Okay, so let's say that f of x, I'm going to say, is the square root of x, and I'm going to say g of x is 3x squared plus 1. okay? When I do that, it's kind of like saying that h of x, this guy right here, is like taking the 3x squared plus 1 and shoving it into x there. That's what I would end up with, is the square root of 3x squared plus 1. So if we define f of x as the square root of x and g of x as the 3x squared plus 1, then h of x would be written as f composed of g of x. It's like taking this g of x and plugging it in to that function for the square root. And that's how we would define him. Okay, now they want us to do it two different ways because there are multiple answers that you could have done here. So let me give you another example. Let's say f of x and g of x. Let's say now instead, f of x is going to be the square root of x plus 1. Okay, then how do I get this x to change to 3x squared? I just say g of x is 3x squared. And then when I do f composed of g of x, it's like taking this g of x guy and shoving it in that spot, and I would end up with the square root of 3x squared plus 1. Okay, so kind of pause the video if you need to, like, think about that for a little bit, because that is kind of a weird way of thinking of this, but there's kind of how that works. We could have done a third way, and we could have said f of x is the square root of 3x plus 1, and g of x is x squared, because I'm taking x squared and I'm plopping it in for x. So if I do f composed of g of x, I'm taking that g of x and I'm plugging it in for the x there, and that will give me the same thing again. So there are quite a few different answers. This one has probably 3. I think that's about all that I can do, maybe. But there's some of the problems that we would do like this, where I'm composing one inside of the other. Maybe they have like 6 different ways that you can write it. Okay, the most obvious one is the first one that we did. Ways of sticking one function inside of the other and having it be a composition. Okay, example 6. They say let g of x be the absolute value of x and f of x be the square root of x. And what they're wanting us to do is f composed of g of x. Okay, so f composed of g of x. So I start with the outside function. The outside function was the square root of x. And instead of putting, that x in there, I put my parentheses and I put g of x, which is the absolute value of x, and I put it in that spot. So I have the square root of the absolute value of x, which kind of looks weird. Okay, to illustrate this, let's go ahead and let's do a table here. So I'm going to do x and y, and I'm going to pick really nice numbers because I know how this is going to turn out. I'm going to pick -4, 1, 0, no, excuse me, -4, -1, 0, 1, and 4. Okay, so let's plug these numbers in and see what this ends up looking like. Okay, so let's say I take -4 and I plop him in here. I'm going to do the absolute value of -4 first, which is going to change that to be a +4, and then I take the square root of +4, which is 2. Now notice it's not plus and minus 2 because we didn't put the square root in there. It's just 2. Okay, we're going to do the same thing again, but we're going to plug -1 in there, and the absolute value of a -1 is going to turn to +1, and if I take the square root of +1, it's 1. Okay, let's go through and do this again with, there we go. Let's do this again with 0. So if I plug 0 in here, the absolute value of 0 is 0, the square root of 0 is 0. Plugging 1 in, the absolute value of 1 is 1, and the square root of 1 is 1. If I plug 4 in, the absolute value of 4 is 4, and the square root of 4 is 2. Okay, so if we plot those, we have -4, 2. We have -1, 1. We have 0, 0, 1, 1, and 4, 2. And so what he's doing is he kind of looks like an absolute value, a square root, but he's flipped over to the other side as well. It says, describe the relationship between the graphs of f and f composed of g in terms of transformations. Well, it's almost as though we've taken this square root function, this guy over here, and we've reflected it across the y-axis. okay? And the reason why it does that is because now, instead of only having positive numbers inside of my square root, because I'm doing that absolute value, which switches everything to a positive number, it allows me to have the graph on this side as well. Okay, so a reflection across the x-axis, that's really what they were looking for in terms of that square root function. Okay, last thing, example 7, a circular puddle of liquid is evaporating and slowly shrinking in size. After t minutes, the radius of the surface of the puddle, okay, so we have a circular puddle, the radius of the puddle is measured by this, okay, in minutes. So if it's been going for, let's see, 1 minute, I would plug 1 in for t, and that would tell me my radius. If it's going for 2 minutes, I would plug 2 in for t, and that would give me the radius of my new circle after it's evaporating. So the circle is shrinking, okay? The area of the surface of the puddle is given by pi r squared, okay? That's just how we find the area of a circle. Express the area as a function of time by finding a composed of r of t, or they write it like this. That's how I like to write it. A composed of r of t, okay? T is kind of like your x variable, so don't worry about the t, but what this is saying is that it wants us to take r of x and shove it into the a equation, okay? So my a equation was pi r squared, okay? And the r is kind of like your x variable, okay? So pi r squared, but in place of that, I'm going to put my r equation, okay, which is 18 over 2t plus 3. Okay, and so now what I have is I have my equation here that relates a to t, the area in terms of time. I don't have to plug the time into the radius equation and then plug that radius equation into the area. All I do is plug the time in, and it will automatically pop out and give me the area. Okay, I completely bypass the radius part of that. Okay, so they want to know what the time is after 12 minutes. So I just plug 12 in for t. So I have pi times 18 over 2 times 12 plus 3, and then I square that. Okay, all right, 2 times 12 is 24 plus 3 is 27. So I have 18 over 27, and really both of those are divisible by 9. So this is 2/3. So this says pi times 2/3 squared. Okay, if I'm going too fast, pause the video. 2/3 squared is 4 over 9 times pi. So I have 4 over 9 times pi, whatever that comes out to be. The radius is 1.5 or something like that. So that is in terms of inches. So there's what the area, not the radius, the area of my circle is, of my puddle, after 12 minutes. Okay, I've completely bypassed the radius part. If I would have left them separate, I would have to take 12 and plug it into this equation, and then plug that number into the area equation. But by plugging the one equation into the other one, I can completely bypass that. Okay. All right, that is what I have for you. I hope to see you on Monday. So we're just going to plan on that.